Good afternoon. This is assignment 2 for COM 381. My name is Kshitij Goyal, and I will just quickly run through the different things that I implemented in this assignment and what I learned, and I will then compare a few things. So, the assignment asked us to work with the MNIST dataset, and that's what I'm doing here. So, I load the MNIST dataset using the TensorFlow Keras dataset. So it's one of the most famous datasets, and so it's easily accessible. So I load that and I do an 80-20 split where I do 80% for training, 20 for test, and then in that training, I do another 80-20 split for training and validation. So this gives me 48,000 training samples, 12,000 validation, and 10,000 test samples. We were first told to train a decision tree classifier, and we're supposed to test different depths. We're supposed to then report the performance of the decision trees that come out of it. And here I test different depths, and here I'm restricting until 25. And then for the last one, I'm saying do it as deep as you want. And so ideally, we would expect that the one that goes as deep as it wants to usually overfits. And yeah, anyway, so this is the code for the the decision trees that I'm implementing. We run our search here. So here for D in depths, we train the classifiers and then we take the train and validation, we plot, and I find the best depth. And here we find that this is one of the models that performed well. So you can see that the train and the validation accuracy, they follow the same, kind of the same curvature, and the train accuracy is 98.5 and the validation is 87.7 and the test is around 87.7 87.8. So this is the best decision tree, and that is at depth 15. And as I said, like the one that overfit got an accuracy of a training accuracy of 100%, validation of 87.3, and test of 87.2. So yeah, that was a decision tree. We did the same for k nearest neighbors. I did grid search here using our validation set, and I found that the best KNN was with three neighbors with a 98.5% train, 97.3% validation, and 97% test. I trained for random forest because this part required us to train three different models and compare. And again, same thing, cross validation. I found the best random forest, which is giving us this train validation and test accuracy. I did on SVM too, and it found that the best kernel to use is the RBF kernel, not the linear one, and the regularization thing was one, which performed the best out of the small sample size I tested. Ideally, when you're testing bigger data sets which are more complicated and they have a lot of different things going on for them, you would test a bunch of other values in these parameters, so the grid search would be bigger. But for the purpose of this assignment, I only did this much. And I finally get the results of all the best models from the ones that we trained, the four models. So decision tree, KNN, random forest, and SVM. And I calculate the scores, and here they are. So our test accuracy was the highest for the random forest, followed by a KNN, followed by SVM, followed by decision tree. And you can see all the different tests and validation. So overall, like I've kind of explained my observations as I was explaining the assignment. And lastly, the random forest and KNN gave the highest test accuracy, while the decision tree clearly overfit when it was not restricted. The SVM achieved good accuracy, but in general, it was quite slow compared to the other models that I trained. And the random forest offered the best balance between the accuracy and the generalization. Thank you.